Today we're looking at isosceles and equilateral triangles, which are two special relationships in triangles. An isosceles triangle is a triangle with at least two congruent sides. Little vocabulary to go along with that. The legs are the two congruent sides of an isosceles triangle. The vertex angle is the angle that's formed by the two legs. The base is the side that is opposite from the vertex angle. And the base angles are the two angles that have the base as a side. So we do have a picture over here. And so let's put some words along with the picture here. So the two congruent sides are marked with one tick mark over here. So these would be the legs. The green side down here would be the base. So these two angles down here that have the base as a side would be our base angles. And this angle here at the top would be the vertex angle. Alrighty. Okay, so we do have a theorem that goes along with the isosceles triangle. It's called the isosceles triangle theorem. It says if two sides of a triangle are congruent, then two angles opposite the sides are also congruent. So this says that if this side and this side are congruent, then that means that this angle and this angle are also congruent. The converse of this is also true. So if two angles are congruent, then the two sides opposite those angles are also congruent. So this one says if we know that this and this are congruent, then we would know that the sides that are opposite from those are congruent. All right, so we have a couple of examples to go over here. For this one here, we do have an isosceles triangle. I can tell because there are two sides that are marked with a single tick mark, showing that they are congruent. They want us to find x and then also angle GFH. So this is GFH over here. All right, so because these two sides are congruent, that means that this angle that I'm looking for ultimately is congruent to this other base angle over here. Now also, because these two angles are congruent, and I know that the sum of the three angles within a triangle is 180, then I can say that 40 plus 2 times the one that I have an expression for. Oops, that's supposed to be 18. Equals 180. And so now I could solve this for x. So I'm going to start by subtracting 40 from both sides using the subtraction property of equality. So that would give me 140 over here. Then I'm going to use the division property of equality and divide both sides by 2. So that would give me 70. Then I'll use the addition property of equality, add 18 to both sides. So this would give me 88. And then division property of equality again, dividing both sides by 11, and I get x is 8. So now I have my x value. Now I just need to find the measure of GFH. Now because GFH is congruent to the other base angle, then I think the first thing I would do is I would say the measure of angle GFH is equal to the expression that I have for the other one. So that would be 11x minus 18. And then from there, I'll use the substitution property and replace the x with what x is equal to. And then it's just a matter of calculating. So I'm going to do this kind of quick because I'm running short on room here. So 11 times 8 is 88. 88 minus 18 would be 70. And then I would put a degree symbol on it because that is the measure of an angle. All right, so if all of that made sense to you, then you may want to pause the video here and try this second one. If, however, you had some questions still and it didn't quite make sense, just stay with me and we'll see what goes on here. Okay, on this one, there's actually a problem. We can't say that that side is, that angle there is 64, so I'm just going to eliminate that. Okay, so they tell me that this angle at the top, the vertex angle, is 40 degrees. These two sides are the sides that are congruent. And so we're looking for x, and that's all we need on this one. So since these two sides are congruent, I can say that 6x plus 4 is equal to 10x minus 8. So now I would use the subtraction property of equality. I'm going to subtract 6x from both sides. And then I'm going to add 8 to both sides using the addition property of equality. And then the division property of equality, I'm dividing both sides by 4. So I get x is 3. And that's all there is to it. Okay, so once again, this would be a good place to pause the video and see if you can find everything that they're asking for in this one. We need w, x, and y. Okay, welcome back. So on this one, you should have gotten that w was 58 because the three angles of this triangle are add to 180. Then I set it up as 64 plus 2w, since these two angles down here have to be congruent, equal to 180. And then solved, and I got w was 58. Then finding x next. X is a little slice of this right angle over here, so that would mean that x and w are complementary. So I set that one up as x plus w equals 90, and then substituted with the value that I got for w. And then finally we needed y, and y is up here. It is one of the base angles on this isosceles triangle over here. So for that one, I said that x was equal to 2y, and then I substituted x with 32. Now there were other ways to get there, but any way you did it, you should have gotten w was 58, x was 32, and y was 16. Okay, equilateral triangles. That is a triangle with 3 congruent sides and 3 congruent angles. So with this one here, we would say all 3 sides are congruent. And I would also say that all 3 angles are congruent. There we go. Okay, so the equilateral triangle theorem says if a triangle is equilateral, then it is equiangular. So that means if all 3 of the sides are congruent to one another, then all 3 of the angles are also congruent to one another. And the converse of that, if a triangle is equiangular, then it is also equilateral. So if you know that all 3 angles are congruent, then you would know that all 3 sides are also congruent. All right, so a few examples with equilateral triangles here. So they want us to find the value of x and the measure of angle h. So x is a part of this angle over here, and then h is the one that I'm looking for ultimately. Now in the picture, they do show me that it's equilateral by giving me 3 tick marks here. So I know that all 3 sides there are congruent, and all 3 angles are congruent. So if I wanted to find x, which is part of this angle over here, then I could say, well, since all 3 angles are congruent, then I would say 3 times that angle measure would have to equal 180, since the sum of the angles of a triangle is 180. Now from there, I would want to use the division property of equality to remove that 3. So 180 divided by 3 is 60. And then I could solve from there. So from here, I think I'll just go ahead and add 4 and then divide by 8. So I got x is 8. That was one of the answers we were looking for. The other answer is, what is the measure of angle H? So since H is congruent to all of the other angles in here, then H is also congruent to 8x minus 4. And so from here I could use the substitution property, substitute in what I got for x, and then I'm kind of out of room there, so I'm just going to go sideways, which is not a format I usually like, but anyway. So I got 60 degrees. Again, there were other ways to get there, and those would be fine as well, but I just wanted to show it using the given information. Okay, for our second one, they want us to find the length of AC, side AC, which is this one over here. They do tell me that this is an equilateral triangle, so all 3 sides are congruent. And then they give me an expression for each of the other 2 sides there. So in order to find this one, I'm going to set side AB equal to side BC. And then I'm going to solve that for x. So I'm going to subtract 6x from both sides first. And I'm going to add 11 to both sides. And that would give me x is 7. Oops, they didn't ask me for that. So let me try that again. Shouldn't have a box around that one. All right, so they asked me for the length of AC, and I know that AC, the length of AC is going to be equal to the length of AB or BC. So I can actually look at either of these and decide which one of those I like better. So if you're a little shaky on your multiplication tables, you could decide to use either 6 times 7 or 8 times 7, whichever one you know. So I'm going to use 6x plus 3. So this would be 6 times 7 plus 3. And again, I'm kind of running out of room there, so I'm going to go sideways. So 6 times 7 is 42. And 42 plus 3 would be 45. So 45 would be my ultimate answer on this one. Okay, for this next one, I think we're probably going to get to use some of our parallel line theorems. So this will be fun. Okay, so we're going to solve for x and for y. They showed me that these 2 lines are parallel. That's what these arrows on the lines mean. And then I have an equilateral, which also means equiangular triangle in there. They marked it with both the sides and the angles, which is not entirely necessary, but anyway. Okay, so this angle here, let's see, we're going for x first. I know that this angle cut by this transversal between these 2 parallel lines, this angle would have to be congruent to this angle here because they are alternate interior angles. Alternate interior angles are congruent. So I could say that 10x is equal to, and then I would just need to know what this angle is. So if the 3 angles of this triangle sum to 180 and they are congruent to one another, then that means that this would have to be a third of 180, which is 60. I'll write it down as a third of 180 though. So then I could say 10x is equal to 60. Oops. And then x would equal 6. That gives me my x. Now for y is a part of this angle over here. And again, we have a transversal through these 2 parallel lines here. So I could say that this one would be equal to this one here because those are alternate interior. But that's probably a little further than I need to go. I could actually use this one over here. These two angles make a linear pair. So I think for that one, I'm just going to say 11y plus 21 plus this other angle, which I know is 60, 1/3 of 180, has to equal 180. Now to solve this one, I think I'm going to, instead of combining like terms over here, I'm just going to subtract 60 because that's a little bit easier arithmetic. And then I'll subtract 21. So that would be 99. And then divide by 11. So I get y is 9. Alrighty, now at the bottom we have two problems that are truly guided practice problems. So at this point you're going to pause the video and you're going to try these two problems and then come back and see how you did. Alright, welcome back. So on the first one, the value of y was 12, and so therefore RT was 66. On the second one, the value of x was 4, and so the value of dB was 14.5.